Oh, hey kids, you caught me. What am I doing? I'm looking at clouds today. My name is Mike Wells, and I was a former science teacher for 12 years. I'm currently a licensed earth space science and biology teacher who taught middle school and high school students. For the last 9 years, I've been a principal at one of the most successful high schools in the state of Indiana. What are we doing out here in this beautiful field in northern Indiana today? We're talking about clouds. As you can see behind me, we have some beautiful, puffy, cumulus, cotton ball type clouds, which is the stereotypical cloud that most people think of. But I'm not going to be talking to you about the specific type of clouds today. We're going to be talking about how these clouds are formed. Most people think that it's just evaporation that causes clouds, but actually there's 3 requirements that allow a cloud to be formed. So let's go into the lab and I'm going to show you how these clouds are formed, as well as any other cloud that you will see on a given day. Hey everyone, we're back inside now, and as I told you outside, we're going to come into the lab and show you how a cloud is formed, and we're actually going to create a miniature cloud right here in front of you. But before we do that, I think it's important that you know the 3 requirements that allow a cloud to be formed. And all 3 are important, and without any of the 3, a cloud will not form. So let's take a look at them and break them down one by one. First, evaporation. As you can see, we have a beaker here that is heating up and almost to the point of boiling, and water is evaporating into the air. We have water changing from liquid to a gas, and as you can see, the gaseous water particles are rising into the air. So in order for a cloud to form, the first component is evaporation must take place. Second, condensation. This little diagram off to the side over here shows you exactly what's happening as the water vapor rises throughout the United States and the world. As the warm water vapor rises, it's going to cool as it gets higher and higher and higher into the atmosphere. At some point, it's going to reach a level called the condensation level. And what happens at this point is the dew point is met. Now, what is the dew point? That's another lesson that we'll get into later on, but I want to let you know it's the temperature at which air must be cooled in order for saturation to occur. So once it reaches that condensation level, it is cooled to the point where now the gaseous water vapor can now go back to a liquid form. And that's where these tiny water droplets occur in the sky. Most people think when they see a cloud in the sky that it's just little water droplets. And yes, that's true, but there's a third component which is critical. And in my opinion, without this third component, condensation nuclei, a cloud will not be able to form. So what is condensation nuclei? Condensation nuclei is all around us. Dust, dirt particles that are floating around in the air. In the atmosphere, it mainly consists of dirt, smoke, and salt particles from the ocean. So what happens is when these water droplets are in the atmosphere, they need to adhere to a particle, whether it be dirt, smoke, or dust, or salt, in order for the cloud to form. So, now that we know what the 3 components of cloud formation are, let's take a look at how we can create one in the lab. Okay, so let's go ahead and create a cloud. We've already talked about the components necessary for a cloud to form. Let's go ahead and do one in the lab. First, let's go over the supplies needed for the lab itself. We have safety goggles, a book of matches, a rag, a bag of ice, 2 empty jars, and a boiling beaker of water. The first step is to put your safety glasses on. And why are we doing this? Because anytime you conduct an experiment when you're using boiling water or matches, it's always important that you wear safety glasses and also have an adult present so they can supervise the experiment that you're doing. Okay, so let's get started. Let's first of all simulate evaporation, the first requirement for a cloud to form. Take your rag, your empty jar. Carefully grab the beaker of boiling water, and you're going to fill the empty jar 3/4 of water. Next, you take your other beaker that's empty and pour most of the evaporating water into the empty beaker. And as you can see, we still have evaporation taking place because the water is still boiling and it's turning into water vapor. So take the jar and pour most of it back into the beaker. You should only have about 1 inch left of water at the bottom of your first jar. That looks like a little bit too little, so I'm going to pour just a little bit back in. Okay, now we have evaporation, component 1. Let's create the condensation nuclei. Take your book of matches. You're going to hold the match over the jar for about 30 seconds. Drop the match into the jar, then grab your bag of ice, and now we are simulating the cooling effect. Look at what happened immediately. As the water is evaporating and rising up, it's cooling because of the bag of ice. What's happening is the little water droplets that are evaporating are condensing on the condensation nuclei. What we have here in this jar is a miniature cloud being formed. So again, let's recap. And by the way, that is not all smoke from the match. That is an actual cloud that is coming out of the jar. So let's recap. There are 3 requirements for a cloud to be formed. 1, you have to have evaporation. 2, condensation must occur. And 3, condensation nuclei must be present for the water droplets to condense on the solid particle. Thank you.